In the last video I showed you the basic function calls and how we can set up power threading to run threads. You got an output similar to this, and if you downloaded the asset you'll have the example script in the package which will do this. It's this one here. Today I'm going to show you coroutines, all about coroutines, and some more advanced uses which you can use to manipulate threads to achieve whatever purpose you need. So let's go have a look at that. First thing we got here is the coroutines class. Now what I've done is I've put these pre-processors at the top of each example script, so only the one that you uncomment will show up in the game. What we've got here is a coroutine that will call string reverse. All that does is take a string, reverse it, print it out. Pretty simple stuff. So we'll comment out these two and have a look, see what it does. So there we go, string reversed. Now all these other comments that show up from the thread manager, what you can do to remove them if they fill up the console window is you can comment out this line here, and then all you'll see in the console is the output from your game. It's pretty handy stuff. Now this doesn't block errors, I'll show you that. If we go into see how it needs a string, if we just create a class here, this will throw an error and that will still be printed out to the console window. See there, invalid cast exception. And you can come down here and it'll give you what script threw the error and where it is. So in coroutines line 30, coroutines line 30, try to cast a GG object to a string and it didn't work. So exception handling will still print a screen if you have that preprocessor commented out on the thread manager class. Just comment this one out here. Now this coroutine, what it will do is loop, execute, then wait for 100 milliseconds, which means 10 times a second we should set. Save it. There you go, much slower than the last coroutine. This one here, just specified loop with no time, so what it does is it calls string reverse and just blasts through it as fast as it can, doesn't pause at all. And this last coroutine, we'll comment that out, uncomment it. What it does is it has a callback function, which is print returns callback. All it will do is, same as before, reverse a string, but it will return the string, and then this function will collect that string in the args, and my args are 0. We have to cast that to a string because it's an object array, not a string. And to do that you use the start coroutine function, not start coroutine void, and you have to put in angle brackets the return type, which is string. So let's run that and see what happens. There you go, returning string printed backwards. Now these coroutine specifiers, what they are is they specify how this coroutine will behave. So at the moment there's 5 of them. Execute then wait, what that'll do is execute this function, which is the one that is being routined. Let's go back here. And then it'll wait for the given time frame and then go back through the loop. Invoke callback at end, which means it'll invoke this callback at the end of the loop. Pretty simple stuff. Invoke callback at start, will invoke it at start, but the thing with that is if you have a return value, the first time through it will run the callback before it runs the main function in the coroutine, so there will be no return value. So the first time it runs through the loop there will be no values passed to the callback, and it'll handle exceptions if it throws exceptions because there's no arguments, but just let you know. Loop, pretty simple, loops it. And execute, wait then execute is it'll wait the given time frame, then execute the main function here. So they're the 5 coroutine specifiers that are in powerful threading at the moment, and you can mix and match them all you want to create a coroutine. Now I'll show you this other example, comment this out. Fixed update. What this does is function WaitForGameUpdate. All this does is pause the current thread until the beginning of the next update loop, which is here. So when the game starts the next update loop, this will unpause whatever thread calls it. And same for fixed update, will unpause it when fixed update runs. So we can see that here if I run it. See fixed update and threaded fixed update, update, threaded update. And if I pause it, you can see the numbers the same. So it's run through 381 fixed updates, and the threaded one has gone through that many loops as well. Same for update. Now the thing is, if update lags, which I've done here, I've put in a heavy operation in update, you'll see that the threaded update also lags in lockstep with update. So you can see the difference between the two there. If I comment this out, so there's nothing lagging the update loop, run it again, you'll see they're pretty much in lockstep, the two loops. And the threaded update and update, same amount of calls, same fixed update. So just to let you know that if you have lots of code in your main thread update, it will also lag your threaded updates, but not the other way around. If you have heavy code processing in your threaded updates, they won't lag your main game update. And I think that's all for this video. I hope you learned something, and stay tuned for another video.